people ndiyabulisa ndimacheruni goeie more goeie what people good morning, good afternoon, good what it will just depend whenever you are going to watch this video. So this is Prof Manqanqa once again from Let There Be Light tutorial. So today people, I will be going through differentiation rules and and just try to really tune out, not really tune out, but at least try to help you with the things that I believe most learners struggle with, the tricks that I believe most examiners get you. So yeah guys, so the first thing that I need to just straight up people, we have to just know the straight up these rules, know them, go and give yourself time and just memorize them. That's the first thing people. I'll be just straight away with you guys. I won't be trying to sugarcoat things. Go out and try to give yourself time and give yourself time to really know these rules. But you must be careful because people, these rules, they're very limiting because most learners, they face struggles, especially when it comes to chain rule, identifying the function that requires you to apply chain rule, because they know these rules as they appear here on this highlighted rectangle. They know these these derivative as they appear. So guys, please, that thing can be really dangerous because you have to know them in this form, people, because you must understand that if this is the function, and then definitely you know that you will apply a differentiating rule, a power rule. Same thing with your exponential function, but you must know that that function, it's a function of exponential function, but inside that function there is also a function there. So you must to know that, okay, when I want to find the derivative of a exponential function, the natural log of what, of the base multiply by what, by the actual function. But now you have to also multiply that with what, people, with the derivative of the function of the exponent now. Because that's why here people, they don't write, actually there is one here because they derive they found the derivative of x, which is 1. That's why you don't see it. That's why I'm saying these laws are really limiting. So I like them when they appear in this format, because learners, they have they know how to derive these type of functions, but when it comes to your composite function, now when there is a function inside of a function, learners tend to really struggle with that because they're used to functions in this format. So they have to know that all these functions, they have the derivative of x, and the derivative of x is 1, so it's not included. As you can see here, people, it's 1 over the ln, the natural log of the base, multiplied by the number that you're going to find it here, or the value, or the function. But now that function, you have to derive it again and multiply it here. That's why you see dy over dx. So it tells you that the inside function now is also derived. So please give yourself time, people, to get through those rules and know them out, people. Know them out. And also, people, these rules, please, I won't go through them, but please, guys, find time to really understand them. Know them. Because mostly, people, you're going to find questions that include all of them. So you don't won't get a situation by they only ask you to apply the constant rule, ask you to apply the multiple rule, the constant multiple rule or power rule or some of the difference. No, they will just encompass all of these rules, 3 or 4 or 5 sometimes, into one a problem. So you have to know them individually. So here now, I'll just apply them, all of them. The problem that I've chosen, they apply most all of these rules. Sorry. So make sure you find time, go through the questions that will teach you to apply this one individually. So, and then you go to questions, the more complicated question where they include all of them. So guys, please find time. I won't go through all of them. I won't really go through them. So, but please find yourself time to go through that. You know? And the exponential rule and the exponential rule, a lot of learners are really finding it hard to really understand the derivative, because they take these equations for granted, these rules in fact for granted. Please guys, give yourself time. And I like the last twos because they give you that element of what, of the chain rule, because now we have the function of f of x, which is given in this case, but inside that function of exponential, you have also a function of g of x. So you have to, when you have to find the derivative, you're going to derive it, as you know, from the exponential perspective, the ln of the base multiplied by the function itself. But now there is an inside function that you have to derive, multiplied by the derivative of the inside function. That's chain rule, by the way. So it's the same thing here. Please guys, find yourself time and learn those rules. So I'll post this document again. People, make sure you print it out and paste it somewhere before you practice your calculus. You remind yourself these rules and then you go through them. Same thing with these ones, people. I like them because they remind you that element of what, people, that element of this block, that element of chain rule. I love them. So please guys, find yourself time, go through them. Right? So today, people, I'm just going to do with few questions with you guys. I'll probably do 1, 2, and your 3, and I will do this one and this one, maybe this one. Okay, so I'll try to, because I want to shorten this video as much as I can. So I'll try by all means to be a little bit faster, so you can always, people, reduce the playback speed. You can always pause, and then you the pace that you allow the video to go on with the pace that you prefer. So that's all, people. So I'll start with the first question. The first question is that, people, we are finding the derivative of this function. Can you see that? And you must know that what did I say to you guys? I said that the question that I've selected, they will all encompass all the rules. So even the rules that are not named here, people, remember, even the rules that are not named here, people, we're going to apply. So remember, there is a what? Implicit differentiation rule. Implicit differentiation, people. Please forgive me my bad writing. By the way, it's not me. So when I was writing this name, I lost coordination. The hand was writing. I was not in charge. So please forgive me in that part. Forgive my hand. I don't know whether you get that joke, by the way. So guys, also remember, guys, the trig derivative, know them also, guys. F of x is equal to, if the derivative of a sign is cos, the derivative of cos is negative sign, and the derivative of tan is going to be your sec squared. The derivative of sec is going to be your sec tan. Derivative of cot is going to be your negative cosec squared, and then of cosec is going to be negative cosec squared. Another thing that you must also take note of, if you observant, because we mathematicians, we're always looking out for what, people? For patterns. If you check that with deriving a trig function that starts with c, we have a negative answer. C, negative answer. C, negative answer. So take note of that, people. I don't know. I'll try to create a video where I'll give you tricks on how to really memorize this, because I'm still working on that trick to really engrave these derivative rules on my mind, and then if I see it's effective, then I can really try and make it systematic as I can, so I can help you out. So let's go on, people. Let's start with the first question. So the first question here, people, is we're given this situation now. We're given this situation. It's 2, pardon me, it's 2y to the power of 3 plus 4x to the power of 2 minus y is equal to x squared. Oh, not x squared per se, x to the power of 6. So remember, people, when we find that you check the question how it is given to you. So the first thing that you have to define, you have to define about this equation is that this equation is given implicitly, so not explicitly. So meaning it's not given in terms of y is equal to something. You know what I mean? It's complicated that you can't see the given exponent 6 that it's given in terms of y or in terms of x. But the question will always come, people, that find that the derivative of dy over dx. They're asking you to find the derivative of dy over dx. But the implicit differentiation rules tells you that you always check the variable that you are differentiating with respect to. That's the first thing. So in this case, we are differentiating with respect to x. So what does that mean? It means that now, when I derive my x, all the terms that include x, I will derive them. I'll apply my derivative rules normally. But when I derive now the terms that have y, I have to know that I will apply the rules normally, but I will have to add something. I will have to multiply with this thing. So I'm deriving with respect to x. So whenever I derive y, a term that have y, I have to multiply with dy over dx always. So when I derive any term that has y, I have to multiply with dy over dx. So keep that in mind. So that's when you derive as implicitly, so people, or deriving questions or equations that are given implicitly. So this is the case in this case. So it's going to be, I'm deriving a term that has y, so I'm going to have to multiply. After deriving, I'll have to multiply with dy over dx. So it's going to be 3 times 2 is going to be your 6y minus y in the exponent is going to be 2. Multiply, since I'm deriving a value that contains y, multiply by dy over dx. So people, the notation is kind of different. Other people like me, we used to this one. Others, they take this one. Others, they take this one. So different approaches, guys. So use whatever that is convenient to you guys. The most important thing is for you to understand. Now I'm deriving with respect to x, and I'm deriving a term that is x, so it's normal. I'm going to say 2 times 4, it's going to be my 8x minus 1, there is 1, and then minus, I'm deriving this one. When I derive y, it's going to be 1, and then since it's y, I'll have to multiply with dy over dx, and then over is equal to, here it's x, so it's normal, 6x to the power of 5. And then what do I do now? After differentiating, people, remember, you're deriving in respect to x, so every term that has x, you derive it the way you know how. Number 2 now, it's implicitly given, so those that have y, you multiply with dy over dx. Then number 3, we have to get all the terms that have dy over dx on the one side and all other terms on the other side. So meaning we have to transpose this one to the other side, and we're going to be left with these two terms on our left hand side. So it's going to be 6y squared multiplied by dy over dx. It's going to be minus, this one is going to be dy over dx. It's going to be equal to 6x to the power 5. When I transpose this one on the other side, it's going to be negative 8x, guys. And then what else do I need? I need to factor out my dy now, because remember what we are looking for. We're looking for dy over a dx. That's what we're trying to do. So we take whatever. We must make sure that on our left hand side we have dy over dx. So I'll factor it out. So I'm left here with 6y squared, and then here I'll be left with 1 here. And then it's going to be 6x to the power of 5 minus 8x. And then what else? I divide people with whatever that I find on my brackets. What I do on the left hand side, I must also do on my right hand side. So people, another thing is that you'll be taught things in very in an introductory manner, meaning they'll be simplified, but when they assess you, they will assess you with high level type questions. So you need to practice with those complicated, but before you go there, start with those easy ones. So I hope, guys, you can see how we did it, people. Remember, we are finding the derivative of this one, and then this is the answer. Please, guys, start over the video and do the questions again. So the number 2 question that also I want to also check is the one that follows. The number 2 question that follows, I'm going to do this one. It's going to be your 7y squared plus sine of 3x is equal to 12 minus y to the power 4. So people, as you practice more, you will be able to assess the type of question you are given and know which rule specifically you will use. So here I know that, okay, this equation is given implicitly. So this means the implicit rule of differentiation will also apply. Also, I know that, I have an outside function of sine, and then inside I have a function of 3x. So this means now I have a composite function. Composite function, to derive or to find the derivative of a composite function, I have to use what, people? Your chain rule. So I know that before I can even, can you see that? So by just observing, and you will reach this level by just practicing, doing a lot of questions. So here we're going to do that. We're deriving a term that has y, so I know that I have to multiply with dy over dx. So it's going to be this multiplied by this is going to be my 14 y minus 1. There is 1, but I was just deriving the y term, therefore I'm going to add this, and then plus I'm deriving this one. Remember, this one's an outside function of sine, and then an inside function of 3x. So this means my chain rule will apply. So it's going to be the derivative of sine is cos whatever the argument remains, multiply by the derivative of the argument of the function that is inside. The derivative of 3x is going to be my 3. It's x, so I don't do anything, and then I come here. The derivative of a constant is 0. I know that. Minus, I'm deriving y. I know I have to multiply with y over dx. So the derivative of this one is going to be my 4y to the power of 3 multiplied by dy over dx. And then where do we go? Remember, after deriving whatever that has y, dy over dx, we put it on one side. So it's going to be your 14y multiplied by dy over your dx. Then this one, when it comes to this side, is going to be a positive 4y to the power of 3 multiplied by your dy over your dx. And then this now goes to the other side. It's going to be 3 cos of 3x. Can you see that? And then what do you do, guys? You're going to factor out your dy over dx. Dy over dx is going to be, we're going to be left with 14y here, and then here we're going to be left with 4y to the power of 3, and then it's 3 cos this one. And then we know that we want dy over dx to be in the one side, so I have to divide by these terms both sides. 4y to the power of 3. This and this cancel out. Your dy over dx is going to be equal to 3 cos 3x divided by your 14y plus your 4y to the power of 3. So that's the answer, people, we are looking for. Okay, right, let's go through again to the question that follows, guys. I've done the first two, so I'll leave out the rest for you guys. So I'll go through this one and then the last two again. So here, people, we're given this situation now. We're given cos of x squared plus 2y, and then is equal to x multiplied by e to the power of what? Y squared. Oh, here it's plus, then it's going to be equal to 1. So they say we must find what? The derivative, the dy over dx. That's what they are looking for, dy over dx. That's what we are looking for. So the first thing that you need to realize that, okay, one thing, y and x, oh, this equation is implicitly given, so definitely implicit differentiation rule will have to take place. Number two is that there is an outside function and then there is an inside function. Chain rule will have to take place here. And then another thing, people, is that also the realization that, oh, I have two functions here, people, and they're multiplying, they're the product, so I know that the product rule will have to apply. But in that process of applying my product rule, I also need to be cognizant that there is also an inside function of y to the power of there is an inside function of e given to something, and then in that function there's an inside function that is y squared. So I know that chain rule will have to be applied here. So I just hope, guys, you realizing that these questions, they don't just come the way you are taught or the way you know how. So that's why you need to do a lot of practice, and then let's go through it. Let's deal with it. So the first thing, I'll derive the outside function, leaving the argument the way it is, people. And the outside function is this one. It's cos. So the derivative, of course, is going to be a negative sign, and then the argument, you leave it as it is. It's your 2y, and then you multiply by the derivative of the inside. Now, guys, the derivative of the inside is going to be what? 2x, and then plus the derivative of your y, people. Derivative of the y is going to be a what, people? It's going to be a 2, but since you're deriving y, you have to multiply with dy over dx. Okay, sorry, I'm making a mistake here. You have to multiply with dy over your dx. Okay, we're done with this one. Then let's come here, guys. Let's come here. It's going to be plus. I know that the application of derivative need to be applied here. I know that. So the first thing, the product rule, in fact, need to be applied. So I'll derive the first and then I'll multiply with this one. So I'm going to find the derivative of x is 1 multiplied by the second function as it is. Can you see that? And then it's going to be plus here, guys. The derivative of now the second function multiplied with the function is this. So it's going to be your x here, then multiply by the derivative of this function now. But this function, remember, it is a what, guys? It is a chain. It is a composite function. It is a composite function, so I have to apply my chain rule. So the outside function, when I find the derivative of e to the power of something, it's that e to the power of something multiplied by the derivative of this one, which is 2y, multiplied by dy over your dx. Remember that, guys. Remember that. Can you see that, guys? So do you see that I've applied the product rule here now, and I also applied the what, guys? The chain rule there. So that's how this question will come through, guys. And then the derivative of a constant is going to be equal to 0. Okay, let's try and simplify this thing out, guys. Remember, what's the plan? The plan is to make sure you find you put all the terms that have dy over dx on one side. That's what we want to do. So this multiplied by this is going to be on negative 2x sine of x squared plus 2y. Remember, I'm distributing this term in this bracket in this. So I'm going to say negative sign this multiplied by 2x. Same thing, negative sign this multiplied by this. Can you see that? And then this multiplied by this is going to be a negative 2 sine of x squared plus 2y, and then multiply by what? 2y over dx. Can you see that? And then this one, it's e to the power of let me write it. Can you see that, guys? I hope you still following. And then here, what do we need to do? Again, there's not much to do, just have to write it in the nice way. It's going to be 2xy multiplied by e to the power of what? Y squared, multiply with dy over dx. But remember, it's equated to 0 here, because remember that 0 is supposed to be 0. So here, this is the case now. I hope, guys, you can follow. Then what's the thing now? The thing is to get these two on the one side. So how? I need to take these ones, these two, on the other side. Can you see that? Because I want to put the terms that have dy over dx on the one side, and those that contain that does not contain dy over dx on the other side. So this means I'm going to be having your 2x y e to the power of y squared multiplied by dy over dx, and then minus 2 sine of x squared plus 2y multiplied by dy over dx. Can you see that? And then it equals to now. Remember, I started by writing this one here, and then this one here. These two people, I'm transposing them. I want them to be on the other side. Then I'm going to be having something like this, 2x, because when I take this one negative, it's going to be positive here. And then this one, can you see that, guys? And then what do? I factor out my dy over dx. Dy Then when I factor out my dy over dx, I'm left with 2xy multiplied by e to the power and then 2 sine 2y. Remember, I've factored out here and here, I've taken them out. So what's left when I factor my here? When I factor my dy over dx, I'm left with this. When I factor my dy of dx, I'm going to be left with this, which is what you can see here. Then this is going to be your 2x sine of x squared plus your 2y, then plus your e to the power of y squared. And then what you need to do, obviously, what's inside the brackets, you divide, because we want this dy over dx to be alone. This and this will cancel out, guys. So you'll be left with dy over your dx as this form: 2x sine of above, okay, then below you'll have 2x minus your 2 sine. So this is the derivative. So can you see that, guys? Like, it really tedious to do such question, but you'll only be able to deal with such complicated questions, guys, when you know those simple rules. So please, guys, you know that you can always pause the video, guys. You can always play back, and you can always go back to these type of question where I started explaining them, and so that you can follow. So I'm done with this one. So let's go on to the second part. The second part deals with the log, because what happens that what I've realized that they also love, when it comes to chain rule, they love to use the radical signs. They love sign. They love trigs. In fact, they love your trig function. They love, when it comes to chain rule, radical signs, your trigs, your exponential functions. So that's where, guys, mostly you will get tricked on by your lecturers or your teachers. So let's go on, people. I'll do the last three. I'm going to be very quick, guys, because I don't want this video to be too long. So I'm going to do this one, and close it with this one. So we're given this equation that we know it's going to be what? Your g of t is given by your 4 log, minus your ln t. So you just need to know those rules, guys. Those rules. Can you see that? So when you find your g of this, you know that, guys, if you have your log the ax, you know that it's going to be what? 1 over your ln of your base, which is a, multiplied by this. and then multiply by the derivative of x, which is going to be 1. So that's why it's not really included, given it in this format. So you have to know that when you derive your ln x, when you want to find the derivative of ln x, you know that it's going to be 1 over x, nothing much. Multiply the derivative of this is going to be your x. That's why it's 1. It's not included. Can you see that? So please, guys, like, take note of these things. These are the laws most students tend to don't give time. So this one, remember, we are deriving this, and it's multiple of what? Of a constant. So we can factor your constant out, and then find the derivative of log base 3t as you know it. So it's going to be what, people? Remember, it's going to be 1 over your ln of a base, which is 3 in this case, and then multiply by this function that is inside there. And then it's going to be minus the derivative of this one is going to be 1 over your what? 1 over your t. Can you see that, guys? I hope you're following, guys, because I've specifically chosen out this question just to show you these things, guys. I've chosen them just to specifically show you these things. I hope, guys, you're really following. And then you can simplify it further. This multiplied by this is going to be 4 over what? ln 3t. This one in brackets, minus 1 over 80. So this is the answer. Can you see that, guys? I hope, guys, like I'm making sense. I'm hoping. Okay, I'm hoping that I'm making sense, guys. Okay, let's go on again with our question that follows. The question that follows is this one. Can you see that? So it's going to be your y is going to be equal to 7 to the power 5 z to the power 5 minus your e to the power of what? Z multiplied by what? ln z. So the first thing that I need to check, I have two functions and I'm finding their product, so I'm deriving. I'll know that I'll have to derive using the product rule now. Can you see that? So I know these things just by observing the question. I'm used to d what. Can you see that? It's dy over what? dz in this case, because the variable we are deriving with respect to z. So this multiplied by this is going to be your 5z to the power 4 applying our power rule, minus, then I'm deriving now with the product rule. I know that, okay, I have to find the derivative of this one and multiply with this one. Again, find the derivative of this one and multiply with this one. I know that. But remember, I have to put because I'm creating two terms now using my product rules, and they'll be both affected by this negative. Hence, I needed to put brackets. So the derivative of e to the power of z, it's e to the power of z. Multiply by my function as it is, and then it's going to be plus. The first function, I write it as it is, and then I multiply by the derivative of this one. It's going to be my 1 over z. Can you see that now? I hope, guys, you can follow really. And then your function now in a simplified version, it's going to be what? 5z to the power 4. You just distribute your negative. It's going to be negative e to the power of z multiplied by ln z. And then this one is going to be minus, because I'll also be going to be affected by this minus, e to the power of z over z. Then this is your what? Your derivative. And you see that? I hope, guys, you're still following, you're still with me, guys. I know. Then let's go through the second one, guys, that follows. Here, given h of y, and then our y is equal to h of y is y over 1 minus e to the power of y. Oh, okay. I know that, okay, there's a division sign and I have two functions now. Okay, I kind of have an idea that, oh, somehow, guys, I have to apply my what people, my quotient rule. So you have to check the question and know which rules, but you won't know which rule to apply if you don't know the rule individually. So just by applying it on this one, I think it's kind of straightforward. It's not really that complicated. So I know that my quotient rules say that if I have my f over g and I want to find the derivative of this one, I know that I have to derive this one and multiply with this, and then minus, I write as it is. No, pardon, I'm writing f as it is, and then I'm going to multiply with the derivative of this one divided by the square of the denominator function. Can you see that, guys? So this is what we're going to apply here. This is what we're going to do here. So let's get it on. So the derivative of this is going to be the derivative of my numerator function, the derivative of y. Remember, I'm deriving with respect to y, so everything is proper here. It's going to be 1. And then multiply by the bottom function as it is. 1 minus e to the power of minus. I write this one as it is. Then I derive this one. Multiply by the derivative of this one is 0 minus the derivative of this one is going to be your minus e to the power of what? 1. And you see that, guys, because the derivative of the bottom function is going to be this one, because this one is going to be the derivative of 1 is going to be 0, and the minus the derivative of this one is, can you see that, then it's going to be 0 minus this one is negative e to the power of y. So that's why I wrote it in this case. Can you see that? I hope you guys, you're just following. Let's get it on. Then simplifying that, guys, this multiplied by this is 1 minus e to the power of 1, and then minus your or this negative going to be multiplying each other, and then they're going to give us positive, and then it's going to be y minus e to the power of this one. So this is our function, guys. This is our function. Yeah. So guys, I'll also do a follow-up video on more complicated questions that also touch other rules, you know, like your sec, your chord, your tan, you know. So I'll do a follow-up video. I'll upload it again during the week, and yeah, guys. So in the meantime, I hope, guys, you'll really take this video and do a lot of example also based on the knowledge that I've provided here. So from me, Prof Manqanqa, I am signing out, guys. So make sure you subscribe to our YouTube channel, and yeah, man, we continue to learn. Comment also on our comment section, guys, so that you can tell us what to do better next time. Give us any suggestions, the question you want us to cover, or those things. So in the meantime, guys, it's Prof Manqanqa from Let There Be Light signing out.